Okay, in this tutorial I want to show you something that's quite cool, and it helps us to create kind of an automated process for some of our blend shapes while still giving us control over some of that automation, which is really what we want it to be. What I'm talking about specifically is a setup here that I've done for the eyes. Now, it's going to be a little hard to see in terms of the eye rotation here because of the cornea. So what I'm going to do is turn on wireframe on shaded so we can better see that eye. Now what I've got going on here, and it's only affecting this left eye at the moment, is when I drag my my eye control up, you'll notice that the left eyelid is going up with it. This can be controlled a variety of ways. It could be controlled through a driven key, but it can also be controlled through another setup that I've created as well that I'm going to show you here in just a moment. The thing that I want to point out, though, is that although as I drag up my eyes here, my eye control, having this automated setup is great, but there's a couple things that I need to make sure that I still retain control of. First off, it has to stop at some point. It has to stop rotating up at some point, and this eyelid needs to stop moving up at some point. That's just, basically how the body works. We wouldn't expect the eyelid to continue rolling back into the eye socket. So we kind of need to know where that point is. But that's fine. We can go in and we can click on our joints and find out, relatively what is a good value for that. But another thing is that let's say that I have the eyelids here. Or just the eye here, I should say. What if I decide that all of a sudden, as this character is looking in this direction, that I actually really want them to be able to open up their eyelid a bit more? Well, if I have this just directly controlled by a driven key or an expression, for instance, to only be controlled by the amount of, I should say that this is opened only based on the position of the eye, or where the eye is looking, then I've lost a degree of control. So what I want to do here is actually create kind of an additive effect where I can have an automated solution that allows this to happen, but then also gives me the option to be able to continue to either open or close this eyelid in addition to whatever is happening in the automated way. So what I've done here is I've added some extra controls here to just the left eye control, which is an independent way of controlling just this one eye. It makes the googly eye thing, which is kind of funny to watch. So what's happened here is I have gone in and added in a couple custom attributes here. Left upper eyelid up and left upper eyelid down. And if I click and drag on left upper eyelid up, you'll see that it actually has the effect of increasing or decreasing the amount of contribution of the upper eyelid, in addition to what has happened just by default here in terms of moving up and down the rotation of the eye. So this is giving me a nice ability to either add or subtract from what it is that we've added in here. Like if I really want that to stay down as I drag this eyelid up for some reason, not very realistic, but maybe I need that for some reason, it's now given me that control. And that's really important. So what I'm going to do, I've already set it up obviously for this left eye, so I'm going to show you the process that I use to create this and redo it for the right eye now. So what I'm going to do is we're just going to reset our values here, and we're going to go bring this guy back down real quick. And let's quickly take a look at how this is actually set up. And in order to do that, I need to go into my Hypershade. The Hypershade is a wonderful tool, not only to set up materials, but also to set up some interesting relationships between, well, in this case, just some math. And to explain this math, it's kind of a visual way of doing coding without having to write any code. You could think of it that way. And we have to think our way through what it is that we're trying to do here. And so this is a bit more of an advanced topic. And I want you to bear with me here. I've set up the basic conditions here that govern what we saw over here. And in order to do that, I need to talk about a couple of different nodes here that we haven't really looked at before, just so that you're familiar with what they do. The first node I have is what's called a multiply divide node. The next node is called a plus minus average node. And the third one is called a clamp. Now let's just talk about each of those individually. If I drag out a new multiply divide node here, what multiply divide does, clicking on the node here and looking at what comes up in the attribute options, it takes a value that you could put into the first row of inputs, which are basically an x, y, and a z value, and it performs a particular operation between those values and the next set of values that are below it. And it does it based on input 1 x would be, in this case, multiplied by input 2x. Input 1 y would be multiplied by input 2 y. There are a couple of different operations. There's multiply, there's divide, and then there is power, which is basically an exponent. And so what we are basically, in this case, looking at doing is going to be a divide operation. Now we're going to come back and explain why that's the case here in a moment, but in this case it would be 0 divided by 1. 0 divided by any number is 0. So the output of this would be 0. And that output then, as you notice here on the multiply divide node, is something that we can then plug into another node. Basically, this performs an operation here, it does some math for us, and then we can take the output of that and then use that determined value to plug into another value somewhere that maybe we then perform another operation on. So it does start to get a bit more complex that way, but it's also really great because in the background, Maya's doing a lot of math for us. This is the kind of stuff that often you end up having to set up as part of a coded solution, something like an expression or a mel command or even Python, stuff like that. But it's all being taken care of through these nodes. So multiply divide, it takes values and either does a multiply or a divide operation between them. Okay, we will come back to that. The next one that we have is called a plus minus average node. And by the way, what I'm doing here is I've found them over here in my in all my little create menu here, and basically I'm in the Maya utilities. It just makes it easier to find specifically the nodes that I'm clicking on right now. These are known as utility nodes, and if you just click on utilities, it will just show all of them here. So this is the plus minus average node. I just middle mouse click and drag it into my hypershade, and I see it here. Now plus minus average. This does what it sounds like. You have either some values that are being added together, or some values that are being subtracted from each other, or some values that are being averaged together. And you can see that here in terms of the operation, just like we saw on the multiply divide node. There was multiply, divide, and power. Here it is sum, subtract, and average. All right, that's pretty straightforward. Where it gets a little bit confusing is how you can actually work with different inputs here. Now, these inputs are based on whether or not you have a single value, or something that's got an x and a y value, which would be a two-dimensional type of operation, or something that's got an x, y, and a z value, which is a three-dimensional input. And in the case of what we're doing here, we are going to be taking the result or the output of the multiply divide node and plugging it into our plus minus average node. And because a multiply divide operation has x, y, and z, that is three-dimensional, we are going to plug it into our input 3D on our plus minus average node, which if I click on add new item, you'll see I get an x, y, and a z value. And so what this will allow us to do is if we have multiple inputs, then it will, in this case it would be using sum, which means it adds them together. It adds the x values together, it adds the y values together, and adds the z values together. And then that creates another x, y, z output, right? And then that can be used for something else. Okay, cool. Take that on faith. Um, Finally, the last one that we're going to look at here is a clamp. Now, if we go up and find our clamp, there it is, clamp. Middle mouse click and drag. And let's have a look at this. So the clamp basically says, all right, you can input into me any values, but you are going to specify whether or not there is a maximum or a minimum value that can either not be exceeded or gone below. And so, for instance, if I had a clamp that was set to a value of 10, for instance, that means that nothing can go above 10. If I input a value of 20 into my clamp, 20 obviously is more than 10. So what the clamp does is it says, all right, 20 is more than 10. What I output is the maximum that you specified, which is 10. So you input 20 and you get out 10. And the same thing would work in reverse. If you were saying that there's a minimum value that you can't go below, -5, and I gave it -10, then the output would be -5, for instance. And so these are where we're specifying whether or not we have a particular minimum or maximum values that we're trying to maintain, as well as what is the input that we are then trying to pass through here. And then the clamp does the determination of whether or not the input exceeds or goes below the minimum or max values. And for anything that does not go against the max or the min, right? So say that the minimum was 0, the maximum was 10, and the input was 7. Well, that's not more than 10, and that's not less than 0, so we would get back out 7. So what the clamp is kind of like a gatekeeper, and it's just trying to make sure that you don't exceed or go below a particular value. And if you don't, then you just get back out the value that you put in. If you do go beyond it, then you get out either the max or the min. So that's what these different nodes are used for. And I'm going to explain shortly here why I even care about this. So that as we think about the kinds of operations that we want to perform, logically we are actually going to need to use these nodes. All right. Now I've also left an extra little multiply divide over here, which I don't necessarily need. I'm just going to delete that. But let's look at the way that I've previously set up this network here. And in order to understand it, we need to look at the rotation that we get with the eye. Basically, the first thing that I want to do is say, where is the point at which the rotation gets me to having the eyelid at its maximum value normally? Now this is cheating a little bit because we can actually see the result here of what I've created. So when I did this, I had to go through and imagine where the best value, the best place for it would be. As you can see, as I go up here, that eventually that eyelid stops rotating up. If you look at it over on this side where we haven't set this up yet, you can see, all right, that's what I would normally have seen to begin with. And so I basically went in and said, that looks about right, And in order to figure out what the value is, then I need to see the joints. So I just turn my joints back on. And the joint that's affecting things here is my left eye joint in this case. And what I did was I said, well, it's primarily the rotate X value that's having an effect here. And you can see that that's approximately -30. Okay. We're just going to keep that value of -30 in our minds. Even though we're rotating in this sort of what looks like an up direction, as far as the joint's concerned, it's actually a negative direction. So just keep that in mind, -30. Now, if I come back to my hypershade here, and I go into this first multiply divide node, you'll see that I have put into input 2 of my X value, -30. That is, in fact, the value that I said is where the maximum point of rotation of that upper eyelid is going to be. And I also have an input here, which is dynamic, because what this is doing is it's looking at what the input is that I'm getting from my current rotation value of that joint. All right, so that's, what is the current rotation value of left eye joint? Well, it's negative 29.587. And that's exactly the value that I see right there. So what I've done is I've actually plugged in that value into input 1. Why am I doing this? Well, I know that at negative 30, if I rotate my eye up to negative 30, I get to the maximum amount of influence that I want to apply. Now it's probably just gone on. I've exceeded negative 30. All right, right now. Basically, if I were at negative 30 here, exactly, divided by negative 30, I would get a value of 1. And that value of 1 then is something that I would want to pass on to the amount of blend shape influence for opening up my upper eyelid. And in this sense, what we're trying to do is to just say, this is the maximum point that we get to. Negative 30 is going to be the rotation value that I'm saying is where it needs to max out. And then we're going to sample what is our current rotation value, which is this dynamic input here. We divide one across the other. In this case, the value is actually a little bit more than 1. Now, that's where later on the clamp value comes in, the clamp operation comes in, because if we do exceed 1, we want to make sure that we just go back down to 1. All right, the max is going to be 1 in this case. So what we do is we do this division here, and that creates an output. And just remember that there are, in fact, 3 values here, but we're really only concerned with the x value. But those 3 values do still get divided here. So this one's going to be negative 31.791 divided by negative 30. This one's going to be 0 divided by 1, and then again 0 divided by 1. All right, so this as an output then gets placed into my plus minus average input 3D. So here is the first input. This is the one that is being controlled by the multiply divide operation, and it comes out here. It's just reading as 1.1. That's roughly what this is. Negative 31.791 divided by negative 30 is roughly 1.1. And now I have another input 3D down here. What is this? Well, this is something interesting. This is where we're going in and we are using the value that we have defined for ourselves over here on left eye control, which is, in this case, my left upper eyelid up. Remember, this was the one which we were trying to use to add or subtract some of the influence from that eyelid based on, whether or not we wanted to take control over it. So right now I have it set to negative 0.4, which means I've actually removed a little bit of the influence from where it normally would be, negative 0.7, so that it's drooped down a little bit more than it would normally be based on the automatic settings. And you can see here, negative 0.6 right now, that value has come in and is being used here in input 3D. So what is this? This is a sum operation, which means to add. So what we're doing is we're taking the value that we determined over here, this relationship, this ratio between the amount of rotation of the eye joint based on versus the amount of rotation that we said was the maximum rotation, and then we're adding to that whatever value we are trying to control through our own input on the left upper eyelid up control, which in this case is a negative value, which means that what we'll get out of here is something like probably around about 0.5, roughly. So what I want to do here is pass this value to clamp. And why is that? Well, let's just take a look at what we get if we pass the result of this value to our clamp. Right now, that result is coming out, and we again see it's just really the x value that we care about. 0.46, like I said, was roughly 0.5. The reason why it's coming in as a decimal is that just when we look at this guy here, it's only giving us 2 digits. It doesn't really tell us down to a more precise value what that actually comes out to be. So 0.46 is close to 0.5. Now, what this is doing is I've given it a minimum and a max value. I said the minimum value is 0, the maximum value is 1. This input here is 0.46. So what comes out of here is just 0.46. It doesn't exceed or go below the min or max values. But let's take the example of, I have my eyelids open to their max. I got this way up high, and I'm adding to it. Instead of subtracting, I've actually gone ahead and like really cranked this way up. Notice how when I crank this way up, it doesn't actually continue adding more. It has stopped eventually at a certain value, which is like right around there, right? Basically at 0 in this case. And right now I got it set to 2. Like if I just let that go on its own, it would be pulling these eyelids way back into the skull behind the eyes, and of course we don't want that. So look at this, check this out. Right now we have the 1.1, which is what we evaluated from the plus minus, which we evaluated from the multiply divide node, and we got that 2.0, which is what's coming in off of the eyelid, the left eye control. 1.1 plus 2.0, that's going to be like 3.1, 3.122 in fact. All right, that's our input. But our clamp here is saying, no, actually we're just going to max that out at 1. So just to prove this, if I were to take a multiply divide node just as a way to see the output that we get from here, and say, let's take our output and plug it into input 1 there, you can see that this 1.0 that we get right here, that's the result of the clamp saying, nope, your maximum is just going to be 1. You've exceeded it. We don't really need this multiply divide node. That was just to prove a point. Now, the 1.0 that we get out of this, what is that used for? Well, that is going to be used to drive the amount of influence on the blend shape itself. All right, so now that I've probably beaten a horse to death, we're going to go through and we're going to set this up for the right eye. So let's get started with that. So we have some kind of cheating information to begin with, which is great. But before we begin, let's actually kind of reset our values. I'm going to put this back down to 0. Actually, before I do anything else, let me explain why I've specifically chosen the value of 2 here. This is in the case where, for instance, let me just put that at 0 to begin with. If I were to have the eyelids way down, like looking way, 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 way down here, right? Based on the way I have this currently set up, if I were only working with a value up to 1, right? If my maximum was 1, notice how that has absolutely no effect here on this upper eyelid. And that just has to do with the fact that I'm working against some inputs that are already below -1. That just has to do with the proportion of moving this way down. So in order to be able to retain control of the upper eyelid, if I were looking really, really far down and I still wanted to have control over it, I have to actually put it to a value of 2 in order to still, in this very weird, probably not very likely scenario, be able to give myself control over it. And that's why that's set up that way. I also have it going down to -2. In fact, I don't know if it's really necessary to go all the way down to -2 to kind of counteract some of the inverse of this problem. I think I might just have to go down to -1. But my clamp has a minimum value of 0. So even if this is overkill, it's not really going to hurt anything. Okay, so that's a big long explanation. What we're going to do though is come in here now and set up this same kind of system on our right eye. And so we're going to first start out by going in and actually I'm first going to start out by putting that back to where it belongs. We have to add in some custom attributes. Notice how the right eye does not have these controls. And I'm just going to turn off some things right now. I'm going to turn off my joints, just get rid of things that I don't need to see. So we're going to create a right version of what we see here. So this is going to be right upper eyelid up. In order to create an attribute, a custom attribute for any control, what we need to do is go to Modify and go to Add Attribute. All right? And what this does is it will add an attribute to the currently selected object. So what we called it was left upper eyelid up. Okay, so we're going to call it right upper, well actually I'll do spaces, right upper eyelid up. All right? And this is going to be a keyable attribute. That's fine. And it's going to be a float, which means it's a decimal number. And it's going to have a minimum. That minimum is going to be, as we said, -2, and the maximum is going to be 2, and the default value will just be 0. Cool. I'm going to click on Add, and there it goes. That's added that in. Now, this other one that we had here, which we haven't really looked at yet, not a big deal. It's the same kind of principle. It's for the upper eyelid down. So this is going to be right upper eyelid down. I'm going to click back over on my right eye and choose right upper eyelid down. And same values, -2, maximum 2, default of 0, and say OK. Cool. So now we have the exact opposite over here on this side. So let's go about and start to integrate these together. So we're going to start out by pulling over our hypershade here. And I had created a multiply divide node to begin with, but I'm just going to go ahead and delete all those, and we will just start over from the very beginning. So we're going to drag out our multiply divide node. There we go. And we're going to use our existing one up here as kind of our guide. Now, the value that we're going to divide, remember, was -30 because we decided that that was the amount of rotation that was the maximum that we're going for with our eye rotations. And it should be the same on the right eye as it is on the left eye. Our operation is going to be set to divide. But what we need to do now to make it like this guy here is to make sure that this input 1 is getting its information based on the rotation of that eye. So how do we do that? Well, there's a couple of different ways we can do it, but I'm going to do it through the connection editor. And in order to do that, I'm just going to move that hypershade off the screen real quick. We're going to go to Windows, General Editors, and Connection Editor. Okay. In fact, I actually have a little button here I use because the Connection Editor is something I use quite a bit. Little CE button here. I also have buttons here for Add Attribute, Edit Attribute, and Delete Attribute. So similar to what we were just doing before. A lot of these things I use quite a bit, so they go into my custom shelf. Okay, so what we want to do is go in and find those joints. Turn my joints back on, and I'm going to click on my right eye joint. That's going to be the thing that I'm connecting into my multiply divide node. So I clicked on that, and I'm going to choose in my connection editor, reload left hand side. And that's going to load into here all the different attributes associated with my right eye joint. Now, what I want to do is come over here and grab my multiply divide node, and I want to load this into my right hand side. So I'll click on reload right. Okay, so what I'm interested in is the rotation value of my of this particular eye joint, which is specifically the rotate X value. and I need to come in here and find that rotate X value. So I'm just going to scroll down here until I find the section that says rotate. And now I don't want rotate altogether, I just want rotate X. So if I expand out rotate, here I can find rotate X. And, okay, so now that I've found that, I need to decide on the right-hand side, what is rotate X going to control? And so in my multiply divide node, if I come over here and look at this, it is going to go into this X value, which is input 1, which means that I want it to go into input 1 X. All right, so here we find input 1, expand that out. There it is, input 1 X. Cool. I click on that and notice how now this is turned yellow, indicating that its value is going to be determined by the amount of rotation that I get on that eye joint. So as I rotate this up, you'll see that now that has changed to negative 18.155, which corresponds to exactly the amount of rotation I see here in X. Okay, so we made a cool connection there. All right. Now, let me just put this back down to its default position, 0. All right, so what we have now, also sometimes when we create these things, we get these little unit conversion nodes. You can just safely ignore that, just don't delete it. Usually they are hidden, but sometimes they get created as we do these kinds of operations. Now, what we need to do is take this proportion and apply it into a plus minus average node. So we're going to middle mouse click and drag a plus minus average node. I always thought this was funny because I was in a fraternity when I was an undergrad, and my fraternity was Phi Mu Alpha, which is PMA, which is exactly the same thing as what this is. So that's just kind of an inside joke to myself, but I do think about that every time I do this. So what we want to do here is take the output of our multiply divide node, and we are going to put that into, like I said before, the input 3D here, because the multiply divide node is a three-dimensional operation, and so this is the three-dimensional operation equivalent. So we'll just say add new item. All right, now. What I did with this was, I think I've just put it directly into the top one. So, output here, how do we get this? How do we get our output from the multiply divide node into the input 3D? Well, we could click on the little green circle and just click and drag, and it creates this nice little arrow. And I'm just going to click and drag that right onto input 3D. In fact, as soon as I do that, it then expands out to input 3D 0. And don't worry about the rest of the things that expand there. Just go input 3D 0. What input 3D bracket 0 means is this is a three-dimensional input. 0 is actually the first one, the first input here. We could have as many inputs as we wanted, but this is the first one because in computer language, we start counting from 0, not from 1. All right, so that's just how that works. And the bracket number just indicates what the order of these inputs are. Cool. So that's our first one. Now, what is going to be our second one? What are we adding together here? So I'm just going to add another item down here so that we have something else to play with. So what we had originally up here, remember, was in our left-hand side, this was the input coming in from our values associated with, well, in this case it was the left side, left upper eyelid up. So for us now, because we're doing the right-hand side, it's going to be right upper eyelid up. Now, in order to be able to do this, in order to get that connected here, we have to go back into our connection editor again. So I'm going to open up my connection editor, and we will go to the, we don't want this to be on our left side. We want our eyelid control, right eye control here to be our left side. That's what's going to be managing the control here. And the left side, what we're plugging into, this plus minus average node, we are going to reload right. Okay. Now, we want the custom attribute that we created. All custom attributes, by the way, are always at the end. So right upper eyelid up, that's what we want to be the input. And I want to plug that into our, not input 1D, input 2D, but we want to put into input 3D. Remember, we have already put something into input 3D 0, so we're going to put this one into input 3D 1. But we can't just put it into input 3D 1 just in total, because this is just a single value. Right? It's not an x, y, and z value. So it's only a single value. It's just basically an x value in this case. So I'm going to plug right upper eyelid up, expand this out, and just put it into input 3D1 dot input 3D, the x value. Okay, as soon as I do that, that gets popped in there. That's why that turns yellow. And whatever I then start to change the value here on this guy, if I were to come in here and change that up to like 1.5, now down here on the plus minus average node, that is 1.5. Okay, I'm going to put that back to 0. And so now we have this sum operation working properly. So the final thing we need to do is to create our clamp. So we're going to come down here, actually going to go up here, and we're going to get our clamp, drag that in, and so our clamp operation is where we determine what are the min values, what are the max values, and what is our input. Well, if we do exactly the same as what we had up here, our min values were 0, our max values, because we're only looking at this one column, just the x, is 1. So let's just make sure to indicate that as 1 there. And our input is going to be the result, or the output, of what we get from here. Now, what we get from here is from input 3D. So what we're looking at is the output of 3D. Okay, so we're going to take that value, output 3D, and we're going to click and drag that into the clamp input. All right. And now this then has our proper operation for what we're going to then pass as a value to our eyelid blend shape. All right, so let's go and find that particular blend shape so we know what we're trying to target. I'm going to turn off my joints here real quick. I'm going to click on my head, and we're going to go and we're going to find the brows, eyes, and if we look here, it is going to be our upper eyelid up right. Okay, so this is the one that we want to target. So the input in this case is now going to be the clamp. It's going to be the output of clamp. So I'm going to click on that. I'm going to go into my component edit. Sorry, I'm going to go into my connection editor and make sure I load in my clamp. And what I'm targeting with that is going to be the blend shape. I just need to go and get to my blend shape node. I clicked on the head, hit Control A to get into the attribute editor, and now come over here and find my my blend shape brows eyes. It's where I put my blend shape before, and it's the upper eyelid up right blend shape that I've created here. So I'm just going to go down and make sure I select this so that becomes the active selection. So that's actually the blend shape node. That's the active selection. And click on Reload Right, and that will put it in here into the connection editor. So how does this work? Well, I want the output, the evaluation of my clamp node, to be the value that then gets passed to my upper eyelid upright blend shape. So I'm going to take the output, and it's really just the output of what I would normally consider to be like x, right? We've called this x, y, z in all these other cases. However, in the clamped node, it's actually considered to be not a vector, which is an x, y, z value, but rather an RGB value. So it's a color node normally. So just imagine that x, y, z corresponds to RGB. So it's actually going to be output R. And so this is going to now be used to drive our weight for the upper eyelid up right blend shape. So click on that, and now it is connected together. If we go into the blend shape node again, you'll see that now that's turned yellow, indicating that it is being driven by something else. And let's just check to make sure that this is in fact working right. I'll turn on my wireframe unshaded. We'll move our eyelid, eye control up, and you can see definitely that the eyelids are moving along with it. There it goes up, up and down. And then also come in here for our custom controls, and right upper eyelid up, that is also working independently, or I should actually not independently, but in tandem, I should say. It's being evaluated together. So we now have the same kind of control that we had on the left-hand side now on our right-hand side. So that was a big, long explanation to try to just set up what is effectively a fairly straightforward control once you understand the basic logic behind it. Just in terms of cleaning things up, I would suggest, to make things a lot easier for yourself later on, that you adopt a naming convention. For me, multiply divide nodes, I always name MD. So I'm just going to click on that, type MD underscore right underscore upper eyelid up, and I'm giving this the name of the blend shape that it's targeting. So that's up, right upper eyelid up. Plus minus average nodes, as you might have guessed, is PMA. Right upper eyelid up. And clamps, well, I never have chosen a very good abbreviation for clamp, so I just do clamp in capital letters. Right upper eyelid up. And now that's those nodes are now a lot easier to read. And so that is just basically one of many cool operations you can perform for evaluations, custom evaluations of your controls, and using these nodes as an alternative to expressions or coding, using Mel or Python. And these these nodes get performed quite fast. Maya is quite efficient at using these, so there isn't much slowdown when you are creating your animation and trying to get some real-time feedback. I hope this has been insightful, and you just kind of need to start taking this information and applying it to how can you use it in other ways to then create other kinds of custom controls on other blend shapes. So good luck to you, and all the best.